Hey guys, it's Darius. Welcome to InventBox, where the solution is right around the corner. And the topic of this video, we're going to get into textures. The texture is essentially an image. It's how you bring in pictures into your rendering. And I've got a little demo going. So this is a Minecraft-like block. Actually, the textures came from an open source game called Minetest. But the word texture in graphics programming is almost equivalent to just a picture or an image, except that with a texture comes some additional image manipulation, in particular being able to map that image onto a really complex shape by adjusting um, like the corners of the image, and we'll get into that. But first, we have to load the texture from a file somewhere into WebGL and let it initialize itself. So I'm starting with a sort of base WebGL example. Pretty much what we've been working with. Only thing that has changed is I got rid of the color buffer, because since we're going to be, putting an image onto the side of our box, there's no reason to worry about coloring our vertices. Let's see, the other thing you'll see is I wrapped all of the shader code in a function that just calls itself, and that way I can reveal it and hide it. And you'll also see a little repeat function that I made that's going to help whenever we are, since a cube has 6 sides, and you're going to do the same thing 6 times in a row, might as well make a function for shortcut. I'm going to jump down here and make a little section for resource loading. And by resource, I mean textures. So let's say we want to load an image from a file. And the first thing we want to do is we can create a texture object with gl.createTexture. And at some point, we're going to return that texture. But we also need to create an image. And remember, as soon as you set the source of a image element or image DOM object, it will begin loading that image. We can't really initialize the texture until the image has fully loaded, so we'll set an event listener. At this point, we want to bind for the first time, because we haven't really done anything with our texture yet. We're going to use gl.bind texture. It works a lot like bind buffer, or that's the other one. And similar to bind buffer, how we have different targets, and in this one we're using an array buffer, but you could have a buffer of something else. In the same way, we have to tell WebGL what type of texture this is going to be. In our case, our target is a 2D texture. And there are also 3D textures, but I don't think that WebGL supports 3D textures. Maybe WebGL 2 does, I'm not sure. We'll give it our texture object. Now, if you were going to try to wrap a texture around a person or a much more complicated object, you would use software to do that, not try to come up with in your brain or on paper all of the coordinates. So with that in mind, we are going to assign UV coordinates to each vertex. So that's another attribute is what I'm saying, just like color was an attribute. And I'm going to call it UV data, except I am going to use the repeat function. And I'm going to repeat 6 times. And the reason is that it doesn't matter which face you're looking at, I want this square texture to be, the coordinates of the texture are going to be the same on all the faces. They'll be the vertices themselves have different coordinates based on which face of the box you're looking at, but the way that the texture is mapped onto it, the coordinates of the image are going to be the same. So the way this works is you just give it an array, and then it will return a flat array with these items repeated 6 times. And of course, we have to provide like 2 triangles worth or 6 vertices worth of UV data. So let's say that we want to start at 0, 0 and then move clockwise around, which actually you have to follow the same convention that you used in your vertex data. And of course, these are just 2D coordinates. And so this will be the bottom. I wish I could expand this out. Let me get these typed up first. Now I only made 4, of course, because this is a box. But then you can take it from a box to 2 triangles by basically copying the last 2 vertices and then switching their order. The next argument is not width. That's because I'm using an overload or a alternate variation of the text image 2D, where the next argument is the format of the image. This is a gl.rgba for a ping, because remember, ping images can have alpha. We also should say that it is a unsigned byte. And finally, we can provide our image element. Now, if you look at this helper that VS Code gives us, we could also provide a video element or a canvas element. That's interesting to keep in mind. we're done with that long function. The next step is to tell WebGL to generate our MIP maps. Simply specify the target, and it will automatically know to use our texture that is currently bound. So we need a way to tell WebGL how to map the image onto a triangle or onto a face. And so we'll do that with UV coordinates. Each vertex of our box will have, along with its XYZ coordinates in 3D space, it will also have two-dimensional UV coordinates. The first coordinate is U, and then the second is V. And these go from 0 to 1 and 0 to 1. It's kind of like X and Y, except that when you say UV, you are talking about the coordinates on a texture, on an image, essentially. Now, for a box, those coordinates are simply going to be these, going from 0 to 1. It'll look just like this. You don't have to change the shape. But if you were going to try to attach a texture, onto like a sphere, wrap it around a sphere, you'd have to be very intentional about which part of the texture image you assign to which vertice of the sphere so that it gets wrapped around. Now, if you were going to try to wrap a texture around a person or a much more complicated object, you would use software to do that, not try to come up with in your brain or on paper all of the coordinates. So with that in mind, we are going to assign UV coordinates to each vertex. So that's another attribute, is what I'm saying, just like color was an attribute. And I'm going to call it UV data, except I am going to use the repeat function. And I'm going to repeat 6 times. And the reason is that it doesn't matter which face you're looking at. I want this square texture to be, the coordinates of the texture are going to be the same on all the faces. They'll be the vertices themselves have different coordinates based on which face of the box you're looking at, but the way that the texture is mapped onto it, the coordinates of the image are going to be the same. So the way this works is you just give it an array, and then it will return a flat array with these items repeated 6 times. And of course, we have to provide like 2 triangles worth or 6 vertices worth of UV data. So let's say that we want to start at 0, 0 and then move clockwise around, which actually you have to follow the same convention that you used in your vertex data. And of course, these are just 2D coordinates. So this will be the bottom. I wish I could expand this out. Let me get these typed up first. Now I only made 4, of course, because this is a box. But then you can take it from a box to 2 triangles by basically copying the last 2 vertices and then switching their order. So we can start with that one and then this. Now we've got 2 triangles. Yeah. And this should be old news by this point. And now that we added another attribute, we'll have to come down and also put that attribute in our vertex shader. Remember that it's a vec2, and also create a varying, because ultimately these go to the fragment shader, and it will interpolate between 0 and 1 all the way across, and all those intermediate coordinates get created and sent to the fragment shader. Create a uniform. The type is a sampler 2D, but it's really an integer, or maybe it's a floating point, a number. Okay, and it will correspond to the number that is assigned to the texture you select. Okay, so I guess I haven't explained that yet, but once you set this uniform and specify somehow which texture you want, that'll be one of the parameters along with the coordinates to this texture 2D function, and it will take the input texture and calculate the pixel color at that coordinate, and that they actually call that a texel. It's a pixel of a texture. It's really just a pixel, I guess, but they call it a texel. Okay, so how do we choose what image we want, what texture we want, if the uniform is a number? And whenever we bound our texture, we didn't specify a number or anything. So the way that texture storage and identification works in GL is there are a number of empty slots that you can load textures into. However, you can actually create an unlimited number of textures, but you can only load or attach. I think that in WebGL it's 96 in this implementation. You can only attach 96 of them at a time. That is, you could only have 96 of these sampler 2Ds. Now, it would be a very ridiculous shader program that uses 96 textures at the same time. But it's a possibility. So right now, none of our textures are attached. We created one called brick. and we can attach it onto the first slot by running gl.active texture. And then it just takes just a number. Except you have to start with the value or the location of texture 0. And then you can say plus anything from 1 up to 96. I'll just go with texture 0. And now I can bind whatever texture object I want to location 0. Brick will now be bound to location 0. That means that if the sampler 2D uniform texture ID is 0, it will look in slot number 0 or location number 0 and find that this brick texture is right there, and it will use those pixels when creating and rendering our image. Of course, we do need to set the uniform to 0 at the beginning. Well, I mean, you could set it to something else, but since brick is in location 0 and I want it to render brick, I'll set it to 0. If we had 35 textures, then I might set it to 23 to begin with. Now this will not render quite yet. There is one more step, and that is we have to create a definition for our UV coordinates attribute. Just like our position location, I will create a UV location. And this whole thing is going to be roughly the same as the code above. Just finishing some things up here. Let's see if it works. All right, very nice. We covered quite a bit in this video, so let's review a few things. First, we created a load texture function that mainly loaded some our image DOM element and then used text image 2D and some map stuff. We had to create our UV coordinate data along with a buffer and an attribute location to go with it. We modified the shader program by adding a uniform that had a type of sampler 2D that was an ID or a location for where our texture is stored. We also learned about the texture 2D function that takes in that texture ID as well as the coordinates of where to get the pixel color from, called a texel. And then we bound our texture object to one of 96 available slots or locations, remembering to start with the location of the constant gl.texture 0. Finally, we'll set our texture ID uniform to the matching number the matching slot location, but without the constant gl.texture0. If you have any additional questions, if you had trouble getting this example to work, please ask in the comments below. Thank you for watching this video. I'll see you in the next tutorial.